Good morning, Math 2. It's Mr. Hewitt. Today is the 6th of April, and today we are going to be looking at creating linear equations from word problems. Okay, so I'm going to be sharing my screen with you so that you can see the student-facing document as we go through it. So the student-facing document for today is where you're going to learn how to create linear equations using word problems. Okay. So I want you guys to remember that the slope-intercept form of an equation is y is equal to mx plus b. All right. This equation has 4 letters, which we call variables. All right. They all stand for something. Okay. The y stands for the dependent variable, which means that it depends on something else. The m is your slope or your rate of change. Okay. So another word for your rate of change is your slope, or another way of saying your slope is your rate of change. Okay, the rate at which something changes by. All right. X is your independent variable, so that usually means it does not depend on something else. Okay, and B is your y-intercept. Okay, that's also known as your initial value or starting point. All right, good. So let us look at an example. So here it says that Lynn is tracking the progress of her plant's growth. Today the plant is 5 centimeters high. The plant grows 1.5 centimeters per day. Part A says to write a linear model that represents the height of the plant after D days. Part B says what will the height of the plant be after 20 days. So how do we start a problem like this? Well, if we look at the directions here, which is very important, by the way, we should read that first. And that's something we just messed up on, right? So it says to solve each problem using the slope-intercept form of the linear equation. What form is that? Well, we just looked at it. It is right here. So we're going to start by writing this equation. Y is equal to mx plus b. So I'm going to share, I'm going to stop sharing my screen with you right now. By the way, if you do not have this document in front of you right now, please pause this video, go to your Google Classroom and open up this document. This document is the 6th of April, so 4/6/20. Okay? All right. So hopefully you all got your packets, and we are going to use the whiteboard at this time. Okay, we're going to use our whiteboard at this time. All right. So we are going to start, as we said, by writing the slope-intercept form of the linear equation, which is y is equal to mx plus b. Okay. Remember, we said that y is independent. I'm sorry, y is dependent. Y is dependent. M is your slope or rate of change. X is your independent variable, and B is your y-intercept or your initial or starting value. Okay, so the problem, again, the problem says that Lynn is tracking the progress of her plant's growth, and today the plant is 5 centimeters high. Stick a pin right there. Let's list all our variables. We have y, m, x, and b. Let us start right there, okay? Now it says that the plant today, the plant is 5 centimeters high. Now, what is that? Is that our independent variable, our dependent variable, our slope, our initial value? What is that? Well, if today the plant is 5 centimeters high, that is our initial value, or y-intercept, okay? Which we know is b, right? B is our y-intercept, aka our initial or starting point. So that is equal to 5 centimeters. All right, let's keep reading. It says that the plant grows 1.5 centimeters per day. So what is that? Every day the plant is growing 1.5 centimeters taller. That is the rate of change, aka our slope, which is m. Okay, so this plant is growing at a rate of 1.5 centimeters per day. Okay, now we are left with x and y. We need to figure out what those are. Well, these are our variables. One is dependent, one is independent. In order to know which one is which, right, let's look at part B. Part B says, what will the height of the plant be after 20 days? So think about that. Is the height of the plant dependent on the number of days, or is the number of days dependent on the height of the plant? Well, obviously, the height of the plant is dependent on the number of days. Okay? Therefore, our dependent variable, okay, which usually is y, our dependent variable is the height of the plant. And our independent variable is the number of days, okay? Okay, good. So in part A, we're asked to write a linear model that represents the height of the plant after d days. So here we can say y is equal to, we know our slope is 1.5 centimeters times x plus 5. Why 5? Because b is 5. We just said that, right? Now notice that in part A it says the height of the plant after d days. Here I have x days. So we want to change that to d days, okay? Just because they want it that way, all right? X is correct, given that this is the equation, but they want us to write it in d days instead of x days, all right? So d days instead of x days. So what we can say here is that we can say that x is also d, right? We can say in this case x is also d, all right? All right, good. Now let us solve part B. Let us do part B. So part B says, what will the height of the plant be after 20 days? So we know that d represents number of days, so all we're going to do is replace d with 20. So here we're going to write y is equal to 1.5 times 20 plus 5, okay? So y is equal to 1.5 times 20 plus 5, because we're trying to find how tall this plant is after 20 days. So we just replaced d, which represents the number of days. So when we simplify this, what we get? What is 1.5 times 20? Correct, that is 30. Good job, guys. And we're going to put that plus 5 back. Okay. Let's further simplify this. What is 30 plus 5? Obviously, that's 35. All right. So when x is 20, y is 35. In other words, when d is 20, y is 35. Okay. We know that d is the number of days, and y is, what is y? What does this represent? 35 what? Well, if we look at here, it says y is the height of the plant. All right. Now, what units are we talking about in this problem? Are we talking about inches, meters? What are we talking about? Centimeters. There you go. So this is 35 centimeters. All right. So we can say here that it is 35 centimeters tall after 20 days. And what do you think is going to happen each day? The plant is going to grow by another 1.5 centimeters, right? So you should know that the higher this number gets, the higher this number gets. In other words, the higher x gets, the higher y gets, right? That's a linear relationship. As the number of days increase, the height increases. All right. All right, so if you guys aren't very comfortable with that, please shoot me an email, okay? Also see me for our live session tomorrow on Google Hangouts. Please look out for a link in your Google Classroom. Okay, so this is what you're going to be doing today for your independent practice and your exit ticket. Okay, you are going to be writing a linear model and solving linear problems, okay? Just like we just did. All right, perfect. So you guys have a great rest of your day, and God bless. Stay safe.